So you should go over and join Aubrey, or go back and join Kate's group.
But I just don't know where he is.
Yeah, I know, but there's an open desk too.
He's right there.
So you can go over there, join Kate's group, join somebody's group. So we are still talking about proportional relationships. And like we saw in either the last chapter or chapter 2, we want to be able to talk about this in all these different ways. So it's like the web. So this would be our proportional relationship web. So we have a constant of proportionality. We have been calling this the unit rate. So go ahead for today, label some notes. I gotta drag that down onto the screen. Label some notes with today's 4.2.4. I would probably label them proportional relationships. We're gonna just write a couple things down. Sweet. We're gonna write a couple things down before we dive in and have you guys start working. Tiny bit of vocab. So our date is, we're in December now, 12, 4, 21 days till Christmas. Yes. Sure. Yeah, I mean, we're also going to lose a bunch of people for choir, so it's going to get really awkward. We'll deal with that when we need to. 4.2.4 today, still dealing with proportional relationships. So again, you can abbreviate this if you want to. Proportional relationships. Sorry that my R is a little awkward. We have been working with unit rate. The new vocab word you see right, if you've got your book open, if you're there with us yet, and I'm trying to talk a little bit so people can finish filling the plan books and catch up with us. I'm going to start writing and then give you plenty of time to write because this is, it's a couple big words. Constant of proportionality. And this is the only time I'm going to ask you to write this entire thing out. Please don't abbreviate it. You want it in your notes so that you know what we're actually talking about. After this, we will probably refer to it, if we have to write it down, as the CP. Because that's a lot of writing to write constant of proportionality. This is really quite simple.
Good morning, Levi Rhodes. Please
And
come to the
you
office.
already know
Levi
how to
Rhodes,
do this.
Please come to the office. Thank you.
You already know how to find the constant of proportionality. We did this last week, actually. You just don't realize it. Because we called it something different. The constant of proportionality is, I might as well write it in red. So you could, I ran out of space there. So it is the unit rate in a proportional relationship. Trying to abbreviate it for you. So constant of proportionality is a fancy name for unit rate. But the reason that we use that is we can have a unit rate that is non-proportional. Anyone remember the example that I gave you? That would be a non-proportional relationship, like what I have to pay somebody. As soon as it starts, even when my count is 0, I owe money.
Oh, the ice cream one.
Oh, yeah. The ice cream situation where if you have to pay for the cup, Marvin's actually remembering things better than I am. Because that isn't even what I was thinking of. There's also, Allie, a taxi. When you get in a cab, a taxi, or an Uber, I think even. I don't know, Uber's like magic. You just hit some things on your phone. But I'm pretty sure as soon as you get in the car, you owe them money, even if they only drive you a block. You have to pay them for how far they take you, and just to get in their car. That's not proportional. In a proportional relationship, we have the constant of proportionality, like what you get paid for how much you worked, what you pay for pounds of bananas, what you pay for the amount of gas in your car. All of those have those 0, 0 points. If I get 0, I pay 0. So that's when we use the constant of proportionality. It's just the unit rate, but it has to be in a proportional relationship. Cool? Questions? I will never, well, I might ask you, but you can ignore me. I will try to not ask you to write that whole thing out again. We use this, sorry, I guess one other thing that we should write in the notes. you're going to see a couple different forms, and you might have seen this in science already. We start to use this equation that is y equals something. This might be k. Sometimes it's m times x. Y equals kx. Now, you'll also see, and in science, I believe you guys are doing this stuff very soon if you haven't done it yet, y equals mx. Same thing. Same exact equation. Instead of k, they use m. It's a variable. They chose it. I will tell you why, and you're probably going to roll your eyes because it's kind of dumb. So for a long time, this was our slope equation. This was our equation for a proportional relationship. And we would reference the constant of proportionality being this value right here. Eventually somebody, now some of this I'm taking some liberties, I don't know this for certain, but for when I learned math versus going through college versus now, at some point somebody said, wait a minute, if we're calling this the constant of proportionality, let's just change the variable. And I bet somebody was like, well, what do you want to use? C? And they're like, well, C, we don't. We use that for other things like questions A, B, C. What about K? It sounds like constant of proportionality. And instead of using M, they just use K. It doesn't make a difference. That is where we're going to plug in the constant of proportionality. So whatever you write in your notes, whether you just write CP or whatever to it, that multiplier, that will be a number. So I guess we should probably clarify that. That's going to be a number. So we don't keep it as a variable, but at first we talk about, oh yeah, the y value equals the constant of proportionality, constant, I don't know if they decided, times the x value. So one very important constant of proportionality, sorry, you all have this, is how much money you will get based off how many hours you work. So this is going to be my unit rate. When we talk about how much money you're getting paid, what would the unit rate be? What per what? Patrick?
Money per hour?
Money per hour, right? It's got to be something per something. Now, the unit rate, or that constant of proportionality, is always the y over the x, and that is worth writing down. So what Patrick just identified is we're talking about money that we get paid, and it's money per time, normally hours. The money is my y. The time is my x. When you think about the label, you can figure out your y and your x. So let's check out this situation so you guys can work with your teams. Now, before you get upset, this could actually be what you get paid. If you take a job as a server or any typical position, they're allowed to pay you less than minimum wage because you get tips. I'm trying to teach you guys about the real world. But notice that this is for half hours. So as I was looking through this lesson and I read it really fast the first time, I didn't see the half hour and I was like, 423, that's some like highway robbery. But that's for half an hour. So work with your team to build a little table where we're going to say, all right, how much time did they work? How many hours? I guess we could capitalize that. And how much money did they make? Right now, we're told for a half hour, we make $4.23. We need to answer these questions. I'm going to give you a couple minutes to work. What's our constant of proportionality here? Is this proportional? And let's say they work a 40-hour work week. A normal work week is 40 hours. How much will they make in a 40-hour work week? Take 2 minutes. Try that. Your table does not need to be elaborate or fancy. Just a simple table. T-chart, if you will. By the way, you guys should turn in your progressing to masteries. I'm getting those turned around as quickly as possible. I'm going to go ahead and pass these out because I know choir people might be leaving momentarily here. No, I did start recording. So we're recording. So when choir people get called out, the video will be uploaded. I'll upload it during the second block. So if you go to the YouTube link on the Schoology page, it's most recent videos on top. So it'll be somewhere near the top of my list. Okay, I'll tell you walk the wrong way. If you are still progressing, when we do progressing to masteries, that just means you need to try to correct those mistakes or just come see me. So if you do not want to go through like it on your own, or you're like, how did I get this wrong again? Like I tried a new problem again, just come see me. So if you get a progression on a progressing to mastery, just come see me. Or you can do it on your own. Sometimes I really want to see you when I write see me on there because I want to talk with you. Otherwise, you can try it on your own or with the help of friends or other teachers or whoever. When you can take papers out of the classroom, you can use your resources. Let's start chatting about this just in case we lose our choir people, because I heard you're leaving very soon. When we look for the unit rate, why is it called unit rate? Why do we say units as opposed to just rate? Not Patrick. All right.
I was going to say blank for blank.
Close.
It's how much of something per something else.
Why unit? Where do they even say it? Unit. Patrick.
It's the it's like what they're saying, but it's the first. It's like how much it's the base. It's like for every half an hour you get $4.
But that's not the unit rate. The unit rate is always something, Grant, over one of the other thing. If we know that we're talking money per... Hold up. Not yet. If we're talking about one of these, I know most of you did this as I came around and we double this and we get $8.46. From there, hold up real quick, just write this down. We could represent this by saying why the money this person will make is that unit rate, $8.46, times the amount of hours they work. Please write that down, choir people, then get out of here. Have fun at rehearsal. You are welcome. Should be a good time. You're out of class, so it'll be fun. Yeah, for all you know, today's the day I did bring cookies. It's not. I'm sorry. It's hard to bring food to school. People have allergies. And I don't want to kill anybody. Like allergic food allergies. If I make something someone's allergic to it and they have a reaction, yeah, that's not. That's why it's just safer to not do it. Or buy it. So, Alan, what do you think? You're making noise back there. Is this relationship proportional?
Well, yeah.
Why?
Because what I figured out was that so when you add a half an hour, it goes up by 4.23.
So you're saying this and this, if I keep going, like do it again, it's going to keep going up consistently? Yeah, so if we graph this, we get that nice straight line. What else tells me it's proportional? There's got to be one other thing. Because this, like, nice going up could happen when it's not proportional. Think about the graph. What two things did the graph need? Allie, do you want to jump to another group? Kind of look lonely back there. What else did the graph need, guys? I know we're not looking at a graph right now, but we needed a straight line.
For the origin?
Alex, through the origin, what's that mean?
It means that you don't have to.
What about my table? What point needs to be on the table? 0, 0. I have to have 0, 0 as part of my table to be proportional. Will they make $0 when they work 0 hours? Yeah, unless they work someplace that I would like to work, where you get paid for not doing anything. That doesn't happen, right? You have that 0, 0 point, and then, like Alan said, it goes up nice and consistently. It's proportional. But this going up nice and consistently could happen even when it's not proportional. So if I use this equation, y equals 8.46x, this is dollars equals 846 times time. Really, we could change our, like, how the equation looks. Where do I plug in my 40? How do I do this just really easy? All right, we're using cards. Mr. Cooper just went. Oh, no, not. She's going now. Kate's here. Kate, if I'm going to plug in 40, right, this is the thing I know, and I'm looking for a thing I don't know. I could do a proportion, but if I use this equation, where does it plug in? So we're going to use the calculator to get this, but so we talked about y equals kx right in our little intro. We found our constant of proportionality, our unit rate, 846. So we've now, this is essentially y equals 8.446 times x. Would the 40 be the y, or would it be the x? The x, right? Because this, and we'll learn more and more about this, time is our independent variable. What we get paid depends on time. So we set this up, and I'm running out of space. So our money that we make will be 846 times 40. What would they make in a standard work week? Thank you very much, Ella. So, a little over $300. Then you're going to pay taxes and whatever else. Yeah. You're going to give a lot of money to Uncle Sam. You might come home with like $250 maybe. Nathan's like, wait, what? Yeah, so you make about $340. That's gross. That's everything. You guys should know some of these words from Phoenix Fair and all that crap. Your gross income is not your net income, what you actually get. So I always think, like, when you use the net, you don't get everything, right? Some stuff gets through it. So the gross is like the giant school of fish, your money. You take your net, well, what you catch, the rest goes to the government. And, yeah. Get a real job and start paying real taxes, and life becomes, like, real. Oh, man. Or just mow yards and don't pay taxes. You do that since you're a kid. All right, try 56. This should maybe be a little bit quicker. If you get stuck, please call me over. We want to find a unit rate here again, because remember, constant of proportionality is a fancy word for unit rate. Do we think it's going to be hours per mile or miles per hour? Yeah, that makes more sense, right? So our unit rate, we're going to do miles per hour. We want to make a graph. Doesn't have to be super fancy, but set up your y-axis and your x-axis. Knowing that it's miles per hour tells me my y-axis is miles, my x-axis is hours. It's always y over x. So go ahead and build this, work with your team to make sure that we all agree. We can label the axes however you choose, but it has to show the proportional relationship. And yes, this is assuming that you can run at the same speed the whole time. That's why it says she runs at a constant rate. Yes, I see your face. You're like, I'm not running the same speed the whole time. I'm not running any speed for any time. But no, I'll run if I need to, but I'd rather ride. Rather than ride my bike.
I'll just
We're like my grades are cut off. That was the last grade, that mastery. I think everybody's deadline's Friday. The papers and everything will be turned, I think, because we're only in school Monday, Tuesday, Wednesday. So I think when you try to get in as quick as you can, I think Friday. And if people like one, we work with that, but you want to try to figure stuff out. So we go with me, and we're having a team. We're sitting five. Okay, so how's on class? Good, good. Oh, she's got one thing left for me. I'll meet with her on that, like that sort of thing. You don't want to use that. The point is for you to be going on this every day. That sounds bad, right? So you two here. I see a lot of people without calculators, and I want to encourage you. We are at the point where we're using technology to work efficiently. We're not cheating. We're not. Like, calculators are a good thing. I can make my calculator solve this by plugging in the numbers that I have, and the fraction just tells me to divide. So in a calculator, if we do the division, we'll find out the unit rate and then be able to use that to solve problems. I like how calculators get left out 2 feet away from the thing. I'm sure. All of these, those are just random back there. The yellow ones, miraculously, pretty much all stay around. They disappear for a couple of weeks. Hey guys, I have 20 calculators in this room. They're all free. And really, these, if you're trying to buy a calculator, I never was on this train until this year. The multi-views are the best for like user friendliness. So hopefully everybody's got a calculator in front of them. If not, look up somebody else's. If we do 9.3 divided by 1.5, what do we get? 6.2. 6.2, right? That 6.2 has a label on it. A lot of us are struggling with labels, like when I'm grading progressing to masteries. That is miles per hour, because the division we did was miles over hours. So this is miles per hour. Now, that can be a point on my table, on my graph, but to do so, I'm actually going to flip over to my notes page here. So we just got 6.2 miles per hour, and we need to graph this, right? If I make a little table, if I run for 0 time, it goes 0 miles. Make sure you set labels at the top. I always try to go X, Y. We know here X is time, Y is miles, distance. 1 hour, how far do I go? 1 hour. Anybody? 6.2, that's the unit rate, that's the point of the unit rate, it is my 1 hour amount. So if I run for 2 hours, how far do I go? 12.4, I double. Now here's the trick with using these tables and building graphs. Always reference the 1. How do I go from 1 to 3? Triple. Right? If I want to go from 1 to 3. So if I triple 6.2, 18.6. If I do it to go to 4, I quadruple. Doing this is the same as saying, hey, your y value equals 6.2 times your x value for any x value that we choose here. Whatever number I put here, I have friends who literally run for 5 hours. They're training for marathons. If we put a 5 there, we just plug 5 into our equation, do the math. Sorry, your question or answer? For 4, what? So what's 4? Did you say 24.8? And then 5 It's insane, but Nate ran 5 miles, 5 hours yesterday. We get 31. If I ran for 5 hours, I have to like stop for lunch. I don't know if it was all running. I was scrolling through my like little feed and it said that he was working out for 5 hours. That's a Sunday where somebody's getting it. So now we gotta graph this. I'm just gonna erase plugging in the 5 there. Make your X and your Y axes. But remember, we're gonna make our life easy. If you are on graph paper, I would put a point, a box up, box over. Another point, box up, box over. Another point, box up, box over, box up, box over. How will my X axis be labeled? On the table. Huh? Yeah. Hours. So I just have 0 at the origin. Then 1, 2, 3, 4, 5. What should my first tick mark be labeled? 6.2. 12.4. I'm going to skip the 18 because I don't have space there. Could they only run for whole hours? Because right now that's what my graph shows, with the points on there. What's the last thing I actually need to do to my graph? Say it louder. Yeah, connect the dots. It's like my favorite game as a kid. Seriously, connect the dots. Draw the line to show that it's proportional. Put an arrow on the end. They could keep running. And that'll keep going. Dumb question. Is this proportional?
Yeah.
You know, all of a sudden they ran 50 miles. Things like that can't happen, right? That's why we have proportional relationships. Try 57. If you get done with that, go ahead to, well, I doubt we're really going to get to that. Because our choir kids are gone, I was kind of flying. I'm going to give you about 5 minutes to work on 57. This uses fractions. Again, what's better than a mixed number?
Improper.
And improper. So just before you dive into this, remember that. You're right. This is, I don't have a good to do. Yeah, guys, talk. So Annika's not the only person talking. So one question you can be discussing is what over what? Like what is our label going to be? What's going to be on top? What's going to be on bottom? What's the y? What's the x? How do we build that equation to be in y equals kx form?
like passed out there.
Well, what was the point? What was the point?
I'm tired.
Maybe that's how he wakes up.
He's up for like 2 seconds.
So Nathan, what do we want to do to go from 2 batches to 1 batch? Multiply by 2?
No,
Divide by 2. Or, if we want to multiply, what do we multiply by to get to 1? A half. I was talking to Nathan. He just smacked his head off his desk. So, sorry, I know it's not been 5 minutes. It's been like 3. So I take, which if you listen to Annika, which I think we all did, if you take your 8/3, which is of course your 2 2/3, as an improper. Now this would be worth writing out. If we take 8/3 multiply by a half, that gives us 8/6, which really reduces to 4/3. Or if we do division, do 8/3 divided by 2, and because the numerator is even, we can actually just divide the numerator, and we get 4/3. Either way, we got 4/3 from what Nathan told me to do. What is that, and what's the label on that? Yeah? Okay, so that's 1 1/3 if I put it back into mixed, but what's the label on it? Cups per... Cups of flour per how much? What are you making? Batches, right? So that 4/3, because it's the constant of proportionality, that's 4/3 cups per batch. Don't screw that up. It'll taste bad. 4/3. Actually, some recipes give you fractions, some give you decimals, so you have to do a little bit of converting depending on how you think. Okay, so I like that. How do we use an equation to help us? Delaney, what do you think? How do we use an equation here? Do we know our constant of proportionality? Yes. What is it? 4/3. So we, just to build the equation, we just build it knowing our constant proportionality. So we now can say y equals, instead of k, we use 4/3 times x. If this was cups per batch, cups is the x batch. Sorry, backwards. It's always y over x. So the y value that you need and the x value, how much you're gonna make determines what you need, not the other way around. What I need does not determine how much I make. That doesn't really make sense to even say. Now, what I have could determine what I make, but what I need does not. Because our choir friends are gone, I'm only going to do one more piece of this problem and give you guys like over 5 minutes to start homework. If we decide to make 5 batches, how do we solve this? If we decide to make 5 batches, maybe not on it. Multiply what? By? Because our x value is our batches, we would just plug in 5 there. What's 5 times 4? 20. So we would get that the amount of flour that we need is 20/3, which is, what is a mixed? Anyway,
6 2/3.
6 2/3. Alright, take some time to start your homework. If you're working with your teams, you might want to agree on some problems or just start with the first one, whatever. Do a minimum of 5. If you decide to do more, that would be great practice.